Hey everyone, so today we are going to discuss this problem number 11, problem number 11 on quantum mechanics. So let us talk about it. चलिए इस पे बात करते हैं हम. So the energy eigenvalue and corresponding eigenfunctions for a particle of mass m in a one-dimensional potential Vx are E equals to 0 and psi x equals to a divided by x square plus a square, where a is a positive constant. Find the forward potential, right? So let us calculate this thing. चलिए इसको solve करते हैं. So how we can solve it? कैसे करेंगे हम इसको? अगर आप इसको ध्यान से देखिए, तो it's a 1D problem, one-dimensional potential problem. So what we will do that we will simply apply the Schrodinger equation in one dimension. हम इस one-dimensional Schrodinger equation को apply करेंगे, और we will try to solve for the potential, right? So let us write the one-dimensional Schrodinger equation. लिखते हैं. So 1D Schrodinger equation is written as minus of h square divided by 2m del of del x square of psi plus vx of psi equals to E of psi. So this is your one-dimensional Schrodinger equation, right? So it's energy, it's the equation which tells that energy in operator, it is operating on a state, gives you an eigenvalue E multiplied by psi. This is energy operator. ये energy operator है और ये state पे operate करता है psi पे, और ये एक eigenvalue E देता है. So यहाँ पे E already given है, E 0, right? And it is asked what is V, right? This is what it is asked. So just put everything psi here and E here, and then calculate for B. So when we put it here, जब हम इस बात करेंगे calculation, चलिए करते हैं. तो psi is given as a divided by x square plus a square, right? And plus b is a potential is a function of x. ये x का function है और psi is 0, right? Because e multiplied by psi is 0 या e is 0. E 0 है तो psi भी e psi भी 0 होगा. तो कैसे कैलकुलेट करेंगे हम इसको? So you just take it to two-time differential of this function. So how you will take? First you take the dx of this complete function. First time you just break it out into two times derivatives. So first derivative of this will give you a out, as a constant. So what is the differential of x 1 upon x square plus a square? Into x to the power n minus 1. So n is what? Minus 1. So minus 1 and x square plus a square whole to the power minus 2, which gives us power 2. Now the differential of x square plus a square. This gives you a square is a constant, to x square gives you 2x. So this is what we are getting. And then v into n, right? Vx into psi is 0, right? This is what you are getting. So this is first differential of psi, and then second differential of psi you will be getting. So just try to calculate it. So what is the second differential of psi? So it gives you minus of h square divided by 2m into a, and then this differential will give you its multiplier by 2, right? So if you take the first differential with respect to 2x, keeping this as a constant, अगर ऐसे करते हैं तो आपको मिलेगा 2 divided by x square plus a square. ये पहला टर्म हो जाएगा. ये simple differentiation है. And the second term will give you minus of 2x and then divided by x square plus a square whole square differential, right? And what is it? It gives you nx to the power n minus 1. So what is nx? It is minus 2, right? As this 2 is minus 2. So nx to the power n minus 1. N minus 1. So what is n minus 1? It is 2 minus 1 is minus 3. Right? This is what you are getting, and then differential of this entire term, right? X square plus a square. This gives you 2x, right? Plus Vx into psi is 0, right? Now let us try to simplify it. What you are getting here, 2, just recheck it whether we are correct or not. So 2 for differential x, and then this, then 2, then nx to the power n minus 1, n is what? Minus 2, minus 3, and differential of x, that is 2x, right? This gives you 2, 8x square plus. So what does it gives you? This gives you 2 divided by x square plus a square whole square with plus sign here, and then this is a minus 8x square, right? 8, 2, x square divided by x square plus a square whole cube plus bx psi equals to 0. Now you simplify it, right? What I have done here, it becomes positive, take minus sign, this becomes positive, this becomes negative. Now you simply multiply 2 x square plus a square minus 8x square divided by x square plus a square whole cube, right? You take the LCM as the x square plus a square whole cube, this divides, leaving you with 2 multiplied by this, and this divided by this, giving you this term. So 2x square minus x square is 6x square, right? Plus 2a square divided by, right? Plus Vx into psi, right? Then what does it gives you? You are getting here 6x square plus 2a square whole cube, right? Into a now 2 cancels out, leaving you 3x square plus a square, right? Equals to minus of Vx into psi. So what does it gives you? So what is psi? Psi is this, a divided by x square. You cancel out both sides. So it gives you a cancels out x square, so it gives you h cut square divided by m into with minus sign, and this gives you 3x square plus a square, right? Yes. Sorry, this is this will become minus, so minus 3x square plus a square divided by x square plus a square whole square, right? As complete term as Vx. So Vx is minus of h cut square divided by m, 3x square plus a square, minus 3x square plus a square divided by x square plus a square whole square. So the answer, let me write it here. Any appropriate plus. So Vx is minus of h cut square by m a square minus 3x square divided by x square plus a square whole square as the potential term. So this is how you can calculate it, right? This is simple calculation, right? So just note it down, and if you have any doubt, please write in the comment section. Here, so let us discuss this problem number 12. चलिए इस problem number 12 के बारे में बात करते हैं. So consider a photon that is scattered from the electron at rest, right? If the photon is scattered at an angle 60 degree with the wavelength lambda dash, that is twice its incident wavelength lambda, then the angle at which the electron reconciles is what, right? So this is a simple Compton effect. There is an electron in a static position, or you can say that a static state, and a photon with a wavelength lambda is striking with it. So what an elastic collision is happening, right? And the photon is transferring some of its energy to electron. So electrons comes into motion, making a deflection of 5 degrees from the actual basically line connecting electron photon, right? So what happens? This angle theta, this is the angle theta, which photons make with its actual direction, and its wavelength is now increased. This is lambda because of the decrease in the energy, right? So let us calculate this reconcile of electron, right? So what happens? You will see first we use the same formula. Relating the lambda and lambda dash minus lambda is equals to h divided by m naught c into 1 minus cos phi theta, right? So here theta is given as 60 degree and lambda dash is given at 2 times lambda. So 2 times lambda minus lambda equals to h divided by m naught c into 1 minus cos 60, which is 1 by 2, right? Giving you h divided by 2 m naught c, right? This cos 60 is nothing but h divided by m naught c and 1 minus 1 by 2. Right? So lambda is given as h divided by 2 m naught c. So you got the lambda, the actual wavelength. Now there is a formula connecting the cos theta and cos phi, which says, angle theta and phi, which says that 1 plus h nu divided by m naught c square into tan theta by 2, right? Where nu is the frequency of incident photon. Here phi is obviously this angle and theta is this angle. So let us just calculate this phi. So how you can find it? So cos phi says that 1 plus h nu. Now what is nu? Nu is nothing but sc by lambda, right? H nu is c by lambda, right? So put in place of nu c by lambda. So 1 plus h into c by lambda into m naught into c square, right? So just cancel c, and then what is lambda? Lambda is given as h divided by 2 m naught c, right? Tan 30 degree. So 1 plus h divided by 2 m naught into c into h divided by 2 m naught c. Right? Hs cancels out, m naught c cancels out, giving you 2, and this is 1 by root 3. Right? So cos phi gives you, this is 1 plus 2 into 1 by root 3. So 3 divided by root 3 gives you root 3. Now what does it mean? So phi is cos inverse root. So this is cot inverse, not the cos. Cot. This is cot phi. So cot inverse root 3. You know that what it is? It is 30 degrees. So phi, angle of reconcile is nothing but 30 degrees. So this is a simple question and here is the answer. बहुत ही आसान है, आप ध्यान से देखेंगे तो और आसानी से कैलकुलेट किया सकता है और आंसर 30 डिग्री एंगल ऑफ फ्रीक्वेंसी ऑफ द इलेक्ट्रॉन. आप इसे नोट डाउन कर लीजिए. Here everyone, so let us discuss this problem number 13, which says that for a particle in a one-dimensional box, the ground state energy is given by E naught. The allowed energies of such a particles are. Wow. So what are the allowed energies? चलिए इसकी बात करते हैं हम. Right? So this is a one-dimensional box, and its energy is given by E naught. So if you recall it by the Schrodinger equation, that the energy of a 1D particle in 1D box. Energy of a particle in a one-dimensional box is how much? Is En. It's defined as n square pi square h cut square divided by 2ma square, right? Where a is the length of the box, m is the mass of the particle, and it's obviously the number of state. So if you consider the mass of the particle as a constant and dimension of size as a constant, that En or energy of the nth state is directly proportional to n square, right? So allowed energies of states in the one-dimensional box are the energies which are proportional to square of the number of state, right? So allowed values are En is proportional to 1, 4, 9 and dot, right? All n square values. Which means that if you take E naught as the 1, so En or E4 will be proportional to 4 times E naught, and E9 will be proportional to 4 times E naught. So 9 times E naught, or similarly. So n square times E naught. So this is the simple question and simple answer. So ये बहुत ही आसान है और आप इसे आसानी से सॉल्व कर इस तरह से कर सकते हैं, राइट? और ये एनर्जी वैल्यू कैसे आती है? आप बाय सॉल्विंग स्क्रोडिंगर इक्वेशन फॉर ए पार्टिकल इन वन डायमेंशनल बॉक्स, राइट? So please note it down, and if you have any query regarding it, आपको कोई भी प्रश्न हो इसके रिलेटेड आप प्लीज कमेंट सेक्शन में लिखिए, so that we can answer it. I mean इसको आंसर दे पाए, right? About this problem number 14 on the quantum mechanics, which says that consider a particle in two-dimensional box whose ground state energy is epsilon naught. Then the energy equal to 13 epsilon naught is how many fold degenerate, right? So this epsilon naught, how is the energy of a two-dimensional box is defined? So En, if you recall it, En is proportional to n1 square or equals to n1 n2 rather than is n1 square plus n2 square pi square h cut square divided by 2ma square, where ma is considered the size of the box, right? And 2 are the states. So if epsilon naught is the energy of the ground state, then what is the energy of this state, which is 13 epsilon naught, right? So 13 epsilon naught means 13 times the epsilon naught, which is the ground state energy. So it is what it is? It is 2 square. So if you take the filling of the energy, the possible values of energy are E11, E12, 21 as the one state, right? And then you have E22, and then you have 23, you have E32, right? Now you want 13 epsilon naught, right? Epsilon naught is the ground state energy, right? So it can be like 10 or 01. So in that case, the 13 epsilon naught is this 2332. So it gives you 2 square is 9, sorry 8, sorry 4, and 3 square is 9, which is 13. So how many times this is E23 is 13 times pi square h square divided by 2m square, where epsilon naught is considered at this point. This is called epsilon naught, right? So this is E23 or E32, both are same. It means that two possibilities are there. It means that the energy of the state is 2 times degenerate, right? So 2 times degeneracy is there, twofold degenerate, right? So if you remember how the energy of the particles are filled, right? Energy states are defined, then you can easily find the degeneracy of the states, right? All right. So let us take another problem, which says that a particle is in 3-dimensional box, in 3D box, and its second state energy is 6G, whose second state, first state is ground state, is 6 epsilon naught, right? Then the energy of third state is how many times degenerate? Energy of state 3 is how many times degenerate, right? This is problem number 15. So if you look at it carefully, now we have the 3D box. So how is the energy field? So E, N1, N2, N3 is basically proportional to N1 square plus N2 square plus N3 square, where epsilon naught is this term, pi square h square divided by 2m square, right? This term is there. So this is epsilon naught. So this N1 square plus N2 square plus N3 square, which is there, now how it is filled? So E11, its possibilities are 111 state, 112, 121 and 211 are the possibilities. Second state. Then third state is 221, 212 and 122. Right? So this is your third state, which has the energy 9 times epsilon naught. Right? Who is how state 3 whose energy is 9 times epsilon naught is how many times degenerate. So you can see 9 times epsilon naught is nothing but 3 times degenerate. E221 equals to E212 equals to E122 equals to 9 times epsilon naught, where epsilon naught is this thing, right? 2 square plus 2 square plus 1 square is 9 times epsilon naught. So if it is asked how many times, how to calculate degeneracy of any state, कैसे करते हैं, तो ये आप ये फॉर्मूला हमेशा याद रखिए 1 डायमेंशनल, 2 डायमेंशनल, 3 डायमेंशन के लिए, कि energy of the particle is always proportional to into 1 n square, or n1 square, n2 square, n3 square, right? So accordingly, you whenever you are calculating the energy and its degeneracy, you can simply use these results. Feel how the energy in the states are filled, right? Energy states are filled. So this is your answer. This is 3-fold degenerate. So third state is 3-fold degenerate. So this is all we have in today's lecture. We discussed problem 11 to 15. We will come up with more number of problems in the next lecture. और सारे प्रॉब्लम्स के साथ हम आएंगे अगले लेक्चर में. सो प्लीज़ आप इस वीडियो को देखिए और ज़्यादा से ज़्यादा लोगों के साथ शेयर करिए. आप इसका यूज करिए, मैक्सिमम यूज करिए और सब्सक्राइब करिए, लाइक करिए, कमेंट करिए. इफ यू हैव एनी क्वेश्चन प्लीज़ आपको कोई प्रॉब्लम हो, कोई पर्टिकुलर प्रॉब्लम इज देयर इन रिलेटेड टू these topics, please write us in the comment section. We will definitely go through it and we will try to answer you, right? So these are the way to reach us, right? Thank you.